So in 8.6, we're going to go over parts of similar triangles. We are starting with a few theorems, and what's nice about these is that it shows the picture that goes with them. If two triangles are similar, then their corresponding altitudes or heights are proportional to the lengths of the corresponding sides. So in this one here, we have YW, which is the altitude of the larger triangle, over SQ, which is the altitude of the smaller triangle, and it is proportional to one of the other sides. They chose YZ and ST, but you can use the other side as well, YX and SR. Our next theorem has to do with angle bisectors. So if you have a bisector that cuts any triangle, the altitude or the bisector that cuts it is proportional to one another. So EW of the bisector of the smaller triangle is proportional to UQ of the bisector of the larger triangle. And then it also is proportional to one of the two sides. So UT and DE, or what they don't have listed here is UV and EF. The next one has to do with the corresponding medians. We have a median S and a median J. What it does is it creates two equal segments when it is the median. So P and S are equal, S and Q are equal to each other, and then FJ and GJ are equal. And it creates some proportionalities there. So we have RS and HJ, which is the line that cuts the middle of each triangle, which is the median, is proportional to one of the other two sides. So P to Q and F to G, because it creates that middle segment. Our last one here is an angle bisector that separates opposite sides of one triangle. So basically, if you have an angle bisector, you can set up a side and the bisector part as a proportion. So BP is proportional to CP, those are the two bottom parts. And then BA and CA are proportional, which are the two longer sides. So basically, you can split these into halves.